Hello everyone, welcome to my channel Aptitude Club, and in today's video we'll be discussing this important question on binomial expansion. This question is a previous year CAT question, CAT 2005 where we had this question. Initially it might look a little lengthy for people who don't know or who are not aware of how binomial expansion works. So the purpose of the video is to take you through that and in simple manner relate to how we can expand and then try and apply it to this question and then solve it. Okay, there are multiple approaches to solve this, but in this video I'll try and use the expansion method to approach this question and solve. So let's get started, and who are new to the channel, if you're watching this video for the first time, do subscribe to the Aptitude Club channel, because you'll get a content related to your preparation every day, which you will be useful in your preparation journey for the CAT and other management interest exams. So do subscribe, share it with your friends if you like the content, and let's get started. What was the question basically? So this is what the question actually was, that if r is given by this expression 30 to the power 65 minus 29 to the power 65 divided by 30 to the power 64 plus 29 to the power 64, then what can be the value of r? Okay, so we have four options, so we'll have to figure out what is the value of r. Now this initially looks like a very big number, 30 to the power 65, quite big. To generalize that, let us try and understand a few identities. Okay, now generally there is one identity which all of us know the value of, but I will show you another way of looking at it. Suppose I'll write a square minus b square. This is something all of us know. It is a minus b into a plus b. Quite simple, all of us know this. If I take it a little further, a cube minus b cube, this also we know, a minus b whole into a square plus ab plus b square. Now what I want to observe here is a pattern. We don't need to remember any of the identities, we have to observe a pattern. First pattern is, there will always be a minus b. Always be a minus b. That means you can generalize that a to the power n minus b to the power n is always divisible by a minus b. This is something you can generalize. A to the power n minus b to the power n is always divisible by a minus b. And if you look at the other part of this, suppose I'll take the first part. In the RHS, the degree is how much? Degree is 2. A minus b, always the degree is 1. So I'm left with 1 degree, degree 1. So a ka power 1 and b power 1. If I'm going with the second expansion, degree is 3 now. A minus b degree is 1. So this term, the degree must be 2. And you can observe that a and b are having the powers 2 distributed amongst themselves. Like in the first term, a has got 2, b has got 0. Second term, you can rewrite it in this way, no? It is a square b0 plus a1 into b1 plus a0 into b2. We can write it in this way. So it is like 2 getting distributed between a and b. So I can extend this logic and keep writing the expansion without remembering anything. Like you don't have to mug up anything. Suppose I'll write a to the power 4 minus b to the power 4. In the same manner I can expand a to the power 4 minus b to the power 4. So it is a minus b, again common. I can write a cube. Now the bracket left will have degree 3 because here it is degree 4. So 3 will be distributed between a and b. So first term 3 is 0. Give 3 to a and 0 to b. Then power of a reduces by 1, power of b increases by 1. Then power of a further reduces, power of b increases, and finally b has everything. This is the like normal pattern. A minus b will always be there, and you start with the highest power of a, lowest power of b. Gradually keep reducing the power of a by 1 and increasing the power of b by 1. You will end up with the highest power of b and lowest power of a. I hope everyone is following this pattern. We don't have to mug up this, just understand, and any expansion we can write. A minus b, this will be now degree 4, so power of a is 4. Gradually reduce, and a reduces by 1 each every time and b increases by 1 each every time, and finally b to the power 4. So this principle in general, we can summarize in this way. Like for any expansion a to the power n minus b to the power n, I can take a minus b common. then this is a to the power n minus 1 plus a to the power n minus 2 b to the power 1, a to the power n minus 3 b to the power 2, and so on. I will have a to the power 1 b to the power n minus 2 and finally b to the power n minus 1. Okay, I don't want any of you to remember this. Okay, no need and absolute no need to remember this. Try and understand this. And this is something we always have seen, especially these two identities all of us have seen very widely used also. Identities and algebraic identities based problems, we use this, but we have never thought of it in this way. If we observe the pattern and we'll use that principle in the question mentioned, easily we can get the answer. So going back to the question, this was the question R. So the numerator of R, if I want to expand numerator of R, so I have R as 30 to the power 65 minus 29 to the power 65, and the denominator is 30 to the power 64 plus 29 to the power 64. This is of the form a minus b. So if I only expand the numerator, let me first expand the numerator, because this is of the form a to the power n minus b to the power n. So I can take a 30 minus 29 common, a minus b. Here the degree is 65. In this expression, the degree is 65. A minus b degree becomes 1. So this bracket will be degree 64. So 64 has to be distributed between 30 and 29. So 30 to the power 64. Then power of 30 reduces by 1. Power of 29 increases by 1. Then similarly 30 to the power 62. 29 to the power 2. And this goes on. Gradually we will reach a stage which is 30 to the power 2. 29 to the power 62. Then 30 to the power 1, 29 to the power 63, and at last 30 to the power 29 to the power 64. I hope everyone is following this. We don't have to mug up the expansion, no mugging up at all. Okay, if you understand the pattern, it becomes very easy to solve. So this becomes 1. So now in the expansion, if I'm taking up this and this, I'll keep them as one, bring them together. So 30 to the power 64 plus 29 to the power 64 plus the rest of the terms, all these terms. So it is 30 to the power 63 into 29 to the power 1, so on till 30 to the power 1 into 29 to the power 63. All the rest of the terms I keep it here. So this is how the numerator will look like if you little bit simplify it. Once you have simplified the numerator, now let's try and see what can be the value of R. So R is 30 to the power 65 minus 29 to the power 65 divided by 30 to the power 64 plus 29 to the power 64. We got the numerator as 30 to the power 64 plus 29 to the power 64. 30 to the power 64 plus 29 to the rest of these terms. Okay, let us say, let it be m. The rest of the terms. Can I say m will be a positive entity or positive integer? It will be a very big number, but definitely it is positive. There is no reason for m to be negative. Can I say that? M is definitely greater than 0. In this case, look at what you are multiplying. 30 to the power 63, 29, 30 to the power 62, 29 square, 30 to the power 61, 29 cube, and so on. Positive numbers multiply हो रहा है and sum हो रहा है, so m is greater than 0. So no need to necessarily always write. So I can write it as m, this divided by 30 to the power 64 plus 29 to the power 64. Where if you want, I can write the expansion here. M is equal to 30 to the power 63 into 29 to the power 1 plus 30 to the power 62 into 29 square, and this so on. This continues till 30 to the power 1, 29 to the power 63 plus 29 to the power 62 plus 29 to the power 63. 30, 63, 21, 29, 1. Just a second. 30 to the power 63, 29 to the power 1 till this much. But m is necessarily positive. So what do you get? I can just simplify it in this way. It is 30 to the power 64 plus 29 to the power 64 divided by 30 to the power 64 plus 29 to the power 64 plus m divided by 30 to the power 64 plus 29 to the power 64. I can open it up in this way. Now this value is 1 and this value is definitely greater than 0. Greater than 0 to hoga because m is positive and this thing is also positive. So the overall fraction, we don't know what the value is, but definitely it is positive. So can I say r is 1 plus something positive? So 1 plus something positive. This implies I'll say r is definitely greater than 1.0. It has to be greater than 1. 1 plus something extra, so r is definitely greater than 1. Very simple. So once you understand this expansion, this is a very easy question to solve. Solving is only this much. All you need to do is understand how a to the power n minus b to the power n expansion works. So I told you two important things. One is this expansion and then one is this property. Very important and used in case of remainders. In a CAT exam, you do get questions from remainders and this principle is used in case of remainders also. Okay, so how you play with identities, how you extrapolate, so that logic must be very clear so that it will help you think for new questions in the exam. So hope all of you understood this question. It's a very important question, and CAT 2005 we had this question in CAT 2005 using expansion method. I solved this. So hope all of you understood this question. So that is it from my end for this session, and hope all of you liked the video, and if you have watched it this far, do subscribe to the Aptitude Club channel. We'll meet again very soon in yet another video. Till then, keep solving, keep studying, and thank you for watching. Bye bye.